In this lesson, I'm going to show you how I like to detect Doji candles in my scripts when working with the Doji candlestick pattern. So let me start by getting some user input. The input we need here is the max wick size of our dojis and the max body size. So here I'll say max wick size equals input.float. We'll give it a title of max wick size and a default value of 2.0. So what this means is that when we detect a doji, let me find an example here. Here's a good example. So this pattern right here has a very small body, as you can see there. But it's not a doji candle technically because the top wick is massive compared to the bottom wick. This is more like a shooting star candle than a doji candle. This, however, is more like it. This pattern right here is a doji because the bottom wick is very similar to the top wick. So what we're going to do here is create an input where the user can specify how much larger one wick can be than the other before it's considered invalid. So by default, the top wick must be within 2 times the size of the bottom wick. If it's bigger than that, then the pattern gets ignored. The next input we want is the max body size. And this is also a float, input.float with a title of max body size. And this is going to have a default value of 0.05. And this value is a percentage. So this is the body size percentage, the maximum body size percentage in relation to the total candle. So by default, we want a candle where the body of that candle is 5% of the total size or less. So this right here probably will not be detected as a doji by this code because the body is much greater than 5% of the total candle size. This, however, may be detected as valid. Now, obviously, you can tweak this number if you want to. That's the point of making it a user input. But we'll get to that later once we detect the actual candlestick pattern. We can start tweaking these numbers to our preference. So the next thing we need to do is get candle data. So we need the top wick size, the bottom wick size, and the body size as a percentage of the entire candle. And then we can compare those 3 values to one another in order to get our valid doji pattern. So the first thing I'm going to do is get the top wick size. So here, top wick size is going to be set to the high minus, and then I'm going to open up some parentheses here. And I'm going to say, is the current close greater than the opening price? If so, then we want to subtract the high from the close. Otherwise, if the open is higher than the close, we want to subtract the high from the open. So here we're essentially getting the highest body, whether that be an open or a close. So in a bearish bar, it would be the open. On a bullish bar, it would be the close. So here I can say reference the close, otherwise reference the open. And now we're subtracting the high from the highest body. And that will give us our top wick size. Next up, we can get our bottom wick size. Now this is in points, by the way. We are getting the top wick size in points. Now for the bottom wick size, we need to do this in the opposite order. We need to get the lowest body, the lowest close or open, and subtract that from the low in order to get this wick size as a positive number. So here I need to say, is the close less than the open? If so, reference the current bar's close, otherwise reference the current bar's open, and subtract the low from that value. And there we have it. We are now getting the top wick size and the bottom wick size in points, price points, on the current bar that our script is running on. The final thing we need to do is get our body percent. Now for this, I'm going to use the math.abs function. So the abs function stands for absolute, and this will convert any negative number into a positive number and leave any positive number as a positive number. So whatever we put in here will be converted into a positive number. That means that we can subtract the open from the close here to get the candle body size in points. And we don't need to worry about whether we are subtracting a bullish bar or a bearish bar. Because if we're dealing with a bullish bar, the open is lower than the close, and so we would get a negative number. Whereas on a bearish bar, the open is higher than the close, and it would be a positive number. By wrapping this value in the math.abs function, we can be sure that whichever candle we are analyzing we'll get the candle size, the candle body size in points as a positive number. And then we can divide that number by the high minus the low. And I need to put that in parentheses as well. Otherwise, Python script might divide our body size by the high and then subtract the low from that value. When in doubt, when you're dealing with mathematical operators, it's always a good idea to just wrap your calculations in parentheses so that you don't need to worry about the operator precedence. We can be certain that this code is going to divide our candle body size by the total candle size. And that's all we need. That's all the data we need in order to determine if the current bar is a valid Doji candle. Now, to detect a Doji, we need to do three things here. We need to check, is the top wick size less than or equal to the bottom wick size multiplied by the max wick size setting, this setting here. So by default, that's 2 times the size of the bottom wick. And is the bottom wick size less than or equal to the top wick size multiplied by that same max wick size parameter. And then finally, we need to check, and is the body percentage, the candle body percent, less than or equal to our max body size, this value here. And that's it. Now we can draw dojis onto the chart using the plot shape function and get rid of this plane A. And I can pass in my doji series or value variable here, this doji variable. I can set the style to shape dot. Well, now we don't know if it's a bullish or bearish doji yet. So let me leave this as shape.xcross for now, and we'll come back to this in a moment, and we'll figure out how to handle bullish and bearish dojis. So let's just leave that as it is for now, save our code, and see what happens. So there we go. Our code is now detecting doji candles. If I zoom right out, there are several examples here of doji candles and invalid doji candles. We can tweak our variables here, so I could set this to 10% of the total bar size. And now we're detecting even more doji candles, and we're pretty much done. All that's left to do now is add filters to this candlestick pattern to increase its accuracy. So a doji candle is supposed to represent indecision in a market, and so it's usually a sign of an impending reversal. So this is a good example. Price has rallied, then it kind of stalls a bit, flattens out, we get a doji candle, price reverses. So what we should probably do here is add a filter to these dojis and only detect swing high and swing low doji candles. So let's do that now. Let me add some code here. We'll say get our filters. So let's do swing high and swing low. Now this will work the same way as our fractal engulfing candles did, except this time, instead of checking if the current bar is the swing high or the previous bar is the swing high, we only want to check the current doji bar's high. So here I can say, is the current bar's high equal to TA.highest? So the highest high over the past 10 bars. Now you could put this into a user input if you want to. I'm not going to bother right now to save time, but if you want to, you could do that. I'm also going to check swing low against the TA.lowest low in the past 10 bars. So now let's split our dojis into 2 different types. Let's have doji bull and doji bear. So doji bull is going to be bullish dojis, doji bear is going to be bearish. So for a bullish doji, we want to check, do we have a doji candlestick pattern? And is that pattern a swing low? Then we can do the same for bearish. Do we have a doji pattern, and is that pattern a swing high? Now let's change this plot shape to plot 2 different doji types. We can change doji bull to triangle up and bearish to triangle down. We need to change the location to location dot below bar for bullish patterns and set the color to green, and location to location dot above bar and color to red for bearish dojis. Now let's save the script and see what we get. There we go. So now we are detecting swing high and swing low Doji candles. Now we could add several more filters to this. We could check if the RSI or MACD or stochastic is overbought or oversold. We could check if the price is above or below a moving average. We could check if the Doji is red or green, bullish or bearish. There are so many different filters we could add to this pattern to increase its accuracy as an entry pattern, entry setup. But I'll leave that to you to play around with based on your trading style and preference. For now, that is how we detect Doji candles in PineScript, or at least that's how I like to detect them. There are other ways to detect them. In the past, I've used pips. I've checked the current bar's pips, body size in pips and things like that, instead of the body size percentage. The problem with that approach is, depending on the time frame you're on, a Doji might be 1 pip or it might be 10 pips or 100 pips on a weekly or monthly chart. And on a 1 minute chart, 1 pip might be a big Doji. And so I like to use body percentage because that scales across all time frames. That's why I go with the body percentage. But anyway, that will do it for today's lesson. I hope you found this interesting. I'll leave the source code, as always, below the video for you to play around with, and I'll speak with you in the next lesson.